this video, we're going to talk about direct, inverse, and joint variation. So I want you to think about the vocabulary. So when we talk about something that's direct, we're talking about something that is like, I would think of it as like straight across. So if I'm going directly somewhere, I'm going straight there. So we already know a direct variation equation, and that would be a very, very simple linear equation called the parent function. So if I'm going to say something is direct, if I say y varies directly as x, I would say y varies directly as x. So let me write that down. So y varies directly as x. So you can see that y and x are both in the numerator. They're on the same line. The only thing that's missing here would be our constant of variation, k. So k is our constant of variation. So if you just take a moment to look at this, you'll see that this looks very similar to y is equal to mx plus b, but in this case there is no b. So it's very, very similar in that way. But what I want you to remember is that direct means direct on the same line. So the next example we're going to look at is inverse. So if I say y varies inversely as x, my x is going to be on the bottom. So you can see it's not directly across. It's as if I had the inverse of y was 1 over x. But we have to remember we have a constant of variation. And my constant of variation is always in the numerator. So if I were going to write this out, I would say y varies inversely as x. Okay? So one way that you can remember inverse is that I could say that 2 is the inverse of 1/2. So you can see one's in the top and one's in the bottom. Now there's one more, and that's joint variation. So in joint variation, I would have something like y varies jointly with x and z. So you can see they're all on the same line. This means together. And again, I have my constant of variation that I call k. So I would say that y varies jointly as x and z. So notice that for all three of these I have a constant of variation. My constant of variation is always in the numerator. Okay? Direct means direct across, joint means together, and inverse is one's in the numerator and one's in the denominator. So we can use any combination of these three when we're talking about direct, inverse, and joint variation. So I'm going to show you how we're going to set this up. So I created a practical problem here, and what we need to notice is that we're going to break this down. So let's just read the whole thing through once. The time required to process a shipment of goods at Xmart varies directly with the number of items in the shipment and inversely with the number of workers assigned. If 15,000 items can be processed by 8 workers in 10 hours, then how long would it take 12 workers to process 20,000 items? So at first you might be like, oh my goodness, this is so many words. But we're going to break it down into 3 parts. So the first part typically will end at the period. So that's our part 1 right there. And part 1 is setting up the equation. So let's put part 1. Set up the equation. Okay, so let's see, what variables do we have? The time required to process a shipment of goods at Xmart varies directly. Whenever I see the word varies, I think equals. Okay? So I'm going to have, use a different color pen. For T, I'm going to use T means time. And then what do I have? The time required to process a shipment of goods varies directly with the number of items. So I'm going to use capital I for items. So I'm going to circle this. I have time and I have items. And then in the shipment, and inversely with the number of workers. So workers assigned. So that means capital W, that's going to stand for workers. Okay. So notice time comes before varies. So that means time is going to come right here. So time varies directly, that's our key word here, directly. So directly means on the same level with the number of items. So I'm going to put I in the same level. And inversely with the number of workers. So inversely means that my workers has to go down in the bottom. The last thing that we have to remember is our constant of variation, which always goes on the top. So I set up the equation. As you can see, it wasn't that hard. I just had to think about the vocabulary and where everything was, and I had to make sure I gave each of my items a variable. Okay, so then we have part 2, which is going to be solve for the constant of variation, okay, which we call K, and write the general equation. Okay. So that means that they have given us, they have to give us some information, and we're not going to be able to do this. So, another highlighter. This is the second part. If 15,000 items can be processed by 8 workers in 10 hours. I'm going to stop there. Notice there's a comma. Okay? So that's usually a good clue. So let me write down what I know. This is what I know. 15,000 items. So items was I, and that equals 15,000. Can be processed by 8 workers. So I know W is workers, and that's 8. in 10 hours. So I know T is 10. Okay, I have my equation. So let's plug everything in. So if T is 10, this is going to be 10 equals, and then my I is 15,000, and my W is 8. And then all I have to do is solve for my constant of variation K. So the easiest way to do this is to multiply by the reciprocal to both sides. Because I know that this is going to divide out to 1. So then that's going to leave me with K is equal to, well, let's do this in our calculator. So I'm going to do parentheses 8 divided by 15,000, close my parentheses, times 10, and I get 0.0053 repeating. I'm just going to go ahead and approximate my answer and keep the decimal. So K is 0.005. So now remember, we're supposed to, after we solve for K, that's what we did here, we solved for K, then we're going to write the general equation. So that means then that the general equation, looking here, that means T is equal to 0.005 times I divided by W. Okay, so now this is my general equation right here. You have to have this. So that's my general equation. So now the last part, which is right here, how long would it take 12 workers to process 20,000 items? So then that last part, which is part 3, is answer the question. Okay, so what do we know there? What did they give us here? So they want to know how long is time, so we don't know what that is. Let's go ahead and do what we did in the previous one. What do we know? We don't know time, but we know we have 12 workers, so we know workers is 12. And what else do we know? We have 20,000 items, so we know that I is 20,000. So now I can take this information, put it in here, and then solve it. So the amount of time is going to be 0.005 times my items, which is 20,000, divided by the number of workers, which is 12. So that means I have 0.005 times 20,000 divided by 12. And that gives me a time equals 8.33 repeating hours. Well, that's kind of funny. I don't know what 0.33 is. So I am just going to do this in my calculator. I know that this is out of 60 minutes. So let's see. I know this is 1/3, so I'm just going to say 1/3, and you can figure that out by putting 0.33 repeating in there. So 1/3 times 60, because there's 60 minutes in 1 hour, gives me 20. So that means that the time it would take 12 workers to process 20,000 items, the time would be 8 hours and 20 minutes. So that's my final answer.